Notice, and this is the regular copyright. We continue with mathematics syllabus for CSEC, effective May-June 2018. The syllabus has not been changed as of January 2026. The structure of the exam is to be changed from 2028. Those 51 videos have been published in their entirety on YouTube. Please make good use of them. The others, some in their entirety and the others partially. Right now, we are at video 16 of 26. And the reason for that is in video 14, we actually did those two. I had hoped to get those three done in one video, but it would run too long. So I did that one in video 15. This one now is video 16, rotation. And that one would be video 17. So those are published in their entirety, these others partially. We are now here, which is this, which is part B of this objective. Transformation using rotation. When this is finished, it will be published in its entirety. As it relates to how the rest of the videos in this section will be published, these 4 more will be published in their entirety and those partially. In this part, we will be dealing with rotation. Before we do that, we need to understand the term clockwise and anti-clockwise or counterclockwise. If you consider this clock over here, it is a digital clock. That will not help us to understand these two terms. However, this clock over here is an analog clock. The hands on this analog clock normally rotates from 12 to 1 to 2, then to 6, then to 7, and back to 12. Like this, from here all the way around, like that. This direction of rotation is called clockwise. It's how a clock operates. So as you could see, clockwise is this direction here. That is clockwise. Now, if you change the mechanism of that clock so that the hands rotate in the opposite direction, then this clock is useless to tell the time. But this new rotation in the opposite direction is called anti-clockwise or counterclockwise. So notice this arrow here. This direction is anti-clockwise or counterclockwise, meaning opposite to clockwise. You need to make sure you get those two terms straight, because every single example we will be doing would be based on either a clockwise or a counterclockwise rotation. Now, the transformation of rotation, as you could see here, is a transformation in which every point of an object turns or rotates through the same angle about the same center in the same direction. You could think of it as a translation, but instead of along a straight line, each point on the object turns or rotates along the circumference of a circle. Now, in addition to the object itself, you will need 3 other pieces of information to carry out a rotation exercise. 1, you will need to know the center at which the rotation takes place. Example, at the origin on a Cartesian grid, 0, 0, or 3, -2. You will also need to know the angle of rotation. Is it 65 degrees? And also the direction of rotation. Is it clockwise or is it anti-clockwise? Now, these two here are normally combined together. So if you see something like -65 degrees, this negative here means a clockwise rotation of 65 degrees. Or if you see positive 65 degrees, that positive means anti-clockwise rotation, and of course 65 degrees. Now, properties of rotation. Whenever an object undergoes rotation, these are the things that remain the same. Preserves distance or length between points on each object. The object is not distorted. It stays the same in terms of length between points on the object. 2, preserves angles. 3, preserves parallelism. 4, preserves area. 5, preserves order of points or vertices. In summary, all points in a plane under the same rotation move through the same angle in the same direction, except the center of rotation, which is the only fixed or invariant point. Now, if you see something like this, that means a rotation at the origin of negative 90 degrees, where all points on the object maps onto corresponding points on the image. So you read that as P is mapped onto P prime under a clockwise rotation through 90 degrees about the origin 0, 0. Or you may see something like this. That's a slightly different way of writing what is over on the left here. And it means P prime is the image of P under a clockwise rotation through 90 degrees about the origin, which is 0, 0. Now, we are going to do quite a lot on rotation. As you could see here, we have 14 examples to do on rotation. The first 6, the center of rotation is 0, 0. They are all anti-clockwise, and in some cases, they touch the axis, one axis, or not. Then from 7 to 10, this one is not at the origin, but the others are. They are all clockwise, and they don't touch any of the axes. 11 to 13, 2 are clockwise, 1 is anti-clockwise. And now we are not dealing with angles of 90 degrees because all of these were multiples of 90 degrees. These are not 90 degrees, and these are not the origin. In one case, the center of rotation is in the object, not of the object. In another case, it is at one side of the object, at the side. And in the third case, it is at the apex of the object. All of those deal with finding image given object. This last one here, we are given the object and the image, and we want to find the center of rotation, the direction of rotation. That one is fairly easy, and the angle of rotation. So those are the things we will be covering in this video. Now you will find out that once you learn this first one here, these others right down to here, they all follow the same principle. So really, you are learning to do that one and then applying it to the other 12. So as I said, if you learn the principles in example 1, then 2 to 13 become very easy. So example 1, I am going to take some time with this one, and with the rest, I will move fairly fast. Consider triangle ABC shown in the diagram below. Draw its rotation of 90 degrees anti-clockwise at the center of rotation 0, 0. So you may see that written like this: rotation at 0, 0 plus 90, which is anti-clockwise, of 90 degrees. So the first thing you will do is draw a construction line from one vertex, say C, to 0, 0, from here to there, and measure an angle of 90 degrees in the anti-clockwise direction. So you start here, measure 90 degrees, put a little mark there, which is 90 degrees. Once you get that, you draw a construction line from 0, 0 through that mark of 90 degrees. From here through this point. Draw that construction line. Once you are finished with that, you draw an arc from C, which is here, using the radius C, 0, 0, that is there to there. The metal point of your compass is here. The pencil point is here. You draw an arc to intersect this line. Label that point C prime. So you draw an arc here, C prime. Now, once you could do that, we will repeat that with the other points, A and B, for this one. And essentially, that is what we'll do for the other 12, essentially. So now, we draw a construction line from another vertex, say B. Remember, we finished that one. To 0, 0. Measure an angle of 90 degrees in the anti-clockwise direction. So we will measure an angle from here to somewhere there. So this is that line. From here, we go that way to 90 degrees. And by now you know what to do. You draw a construction line from 0, 0 through that mark of 90 degrees from here to where that line was marked off. Draw that line. And then you draw an arc from B using a radius of B to 0, 0 from here to there. Metal point of your compass is here. Pencil point is at B. You draw an arc to go to that line, and you label the point where this arc intersects with that line as B prime. Well, you would do the same thing for the next point, which is A, except that we have a little help here. Draw a construction line from another vertex, in this case A, to 0, 0, so it's from there to there, and measure an angle of 90 degrees in the anti-clockwise direction, this way. Now, because A is touching the x-axis, this axis here, this is already in place at the y-axis. So you don't need to draw the line. The line is already drawn for you. You don't need to measure that 90 degree. It is already measured for you. So you draw an arc using a radius of A to 0, 0 to intersect that line to 90 and label that as A prime. So this arc here, A prime. So as of now, we have the image A prime, B prime, and C prime of the vertices of the object A, B, and C. So A prime is the image of A, B prime is the image of B, C prime is the image of C. All we have to do now is, using straight lines, connect A prime to B prime to C prime and back to A prime. Now that will give the image under the given conditions, which is under these conditions. So we connect A prime to B prime to C prime and back to A prime. And that will give us the image under these conditions. These are all the principles we will use in all situations when this is to be done graphically. So once you learn this one for C, you do the same thing for B and the same thing for A. You get the image points, connect them up, and you actually get the image. I did that in detail. The rest I will move very fast. Now, and if you are required to find the image vertices under these given conditions, not using a graph, what will you do? So we use a graph here. What about if you were told to calculate it? You were given this and told one of the vertices of the object. How will you calculate this corresponding vertex on the image? All right, let us say we have this vertex here. Notice it is 4, 0, but on the image, it is 0, 4. We have this one here, B, 11, 2, but this one here is negative 2, 11. This one here is 10, 6. It is negative 6, 10. Do you see a pattern? So let's write them in a table. You will notice that all the original x values now became the y values, and what were the y values now became the x values multiplied by negative 1. In other words, xy on the object becomes negative yx on the image. Now, just to reinforce that rule, using this, we got that from this object and that image. That's what we got here. P object P prime, which would be this first image here. Now, but let us use this image now as the object. Forget that. We are going to use this image as the object and this here as the image. That 0, 4, remember we exchange x and y, then multiply y by negative 1. So if we exchange that and multiply the 4 by negative 1, then this a here becomes negative 4, 0, which is this. And the same thing goes for b, negative 6, 7 would become negative 7, negative 6. And the same thing goes for this c, negative 4, 12 would become negative 12, negative 4. So we are following the same rule here. Okay, let us forget that one and now use this as the object. And how do we get this image here? So we are now using this as object, and let's see if we get that as the image. So this is negative 4, 0. What do we expect here? We expect the y to become x and the x to become y, making that y negative. But since it is 0, it doesn't make a difference. So what do we get here? We get 0, negative 4. We keep the negative 4, which is the x stays as x, which is y now. The next one is b, negative 7, negative 6. We will keep that as y and we will multiply this by negative 1 to become the new x. So we get 6, negative 7. And then for c, we will keep that negative 12. This negative 4 go in the x place, and we multiply it by negative 1. So it becomes 4, negative 12. So it doesn't matter which quadrant we are moving from and to, whether from the first quadrant to the second quadrant, or from the second quadrant to the third quadrant, or from the third quadrant to the fourth quadrant, as long as we are going 90 degrees anticlockwise direction using the origin as our center of rotation, this rule here always applies by calculation. Example 2. Now I will move very fast from here. So what I have done is drawn the 3 lines. Well, actually, all I need to do was to draw 2. From C to O, from B to O, this A to O is already drawn. And I will extend it over this side. And remember, that will give me 180 degrees because we are going through 180 anticlockwise from the origin. So I measure from A using a compass, that would be A prime. Do the same thing with B, that will be B prime. Do the same thing with C, that will be C prime. Now all I need to do is connect A prime to B prime to C prime back to A prime, and we would have accomplished that example. That's our image. That's example 2. In terms of calculation, if that is 4, 0, notice this one over here is negative 4, 0. And if this is 12, 2, that's B. B prime over here is negative 12, negative 2. And this C up here is 10, 6. And this C prime over here is negative 10, negative 6. So if you put that on a table, as you could see, the absolute values stay the same, except that all of them are multiplied by negative 1. So xy becomes negative x, negative y. You don't change or wrong anything. 4, 0, 4, 0. 11, 12, 11, 12. 10, 6, 10, 6. But you just multiply all of the image points by negative 1. And that is same for mirror image as we saw in the last video, which was this. At 0, 0, mirror image. This is what we had. Notice xy becomes negative x, negative y. Example 3. Consider triangle ABC shown in the diagram below. Draw its rotation at 270 degrees anticlockwise at a center of rotation of 0, 0. So as I said, I will move fast. So this is what you are required to do in notation form. Now you do know that going all the way around here, which is 270, is the same as coming this way, 90. So that is what I will do. Draw from B to here, measure off 90 degrees there. Do the same thing. Then draw an arc, and I get B prime from B. This one here can easily be done. I don't need to draw a line because I already have those two axes as lines, 90-degree lines. And that leaves me with C. From C to here, draw a construction line, measure 90 degrees through here, draw a line through there, and then get an arc from C to here. And this gives me C prime. So now I have A prime, B prime, and C prime. All I need to do is connect them. I connect A prime to B prime to C prime back to A prime with straight lines, and that will give me the image on this condition. An anti-clockwise rotation of 270 degrees at the origin. Now, can we calculate that? That is 4, 0. This is 0, negative 4. This is 11, 2. This here is 2, negative 11. This is 10, 6. This here is 6, negative 10. So if you put those in a table, you will notice that the x value became the y value over here multiplied by negative 1. But the y value stayed the same, which became x value here. So this is the rule. xy become y negative x. Let's summarize what we have done so far. At plus 90 degrees, this is what happens. xy becomes negative y x. At 180 degrees anticlockwise, which is the same thing as clockwise, then xy becomes negative x, negative y, which is same for a mirror translation, which is this, and then 270 degrees anticlockwise, this is what happens. xy becomes y negative x. Example 4. Now, this is basically the same thing we were doing, except no part of the object is touching any of the axes. So we'll have to draw an extra line. So from C to there, draw that construction line, measure 90 degrees here, mark that off, draw a line through here, and draw an arc through there. That will give us C prime. You do the same thing for B, construction line, measure 90 degrees through here, mark that off, draw a line through here. Once you get that, from B you draw an arc, and that would give us B prime. Previously that A was touching here, but now it is not, so we'll have to draw a separate line from A to there. From A to there, and measure from that, going around here, 90 degrees, draw that line through there, draw an arc from here to touch that. And so at this point, we have A prime, B prime, C prime, which are the image points corresponding to the object points A, B, C. You draw straight lines connecting them, and you now have the image under these conditions. Now, can we calculate this? 4, 2 becomes negative 2, 4. 10, 4 becomes negative 4, 10. And 10, 9 became negative 9, 10. I've seen that before, which is this. XY becomes negative YX. That was what we got for example 1, when we had this point touching here. So whether it is touching or not, we follow the same principle. We follow the same rule. Under an anticlockwise rotation of 90 degrees at the origin, 0, 0. Example 5. Now we are going to deal with this at 180 degrees. But we did this already when this was resting at this point. So this time you draw those lines going straight through 180 degrees. Take your compass from here to here. Make a mark there along that line, which is A prime. Do the same thing for B, to be B prime. Do the same thing for C. Well, to differentiate that prime from this prime, we will call this A double prime, B double prime, and C double prime. And then once we have those points, we just connect them with short straight lines like this, and we get image 2. That was image 1 at 90 degrees anticlockwise. This is image 2. Can we calculate it? Yes. 4, 2, negative 4, negative 2, 10, 4, negative 10, negative 4, 10, 9, negative 10, negative 9, which, as you can see, xy becomes negative x, negative y. But we have seen that before. And it is the same for mirror image at 0, 0, which is this. Example 6. Now we are going to 270 degrees. We can actually go all the way around to 270 degrees. So we measure these three angles. You could measure 270, or you could measure 90. It doesn't really matter. It is the same thing. So you follow the same procedure. That A becomes A triple prime over here. That B becomes B triple prime over here. And that C becomes C triple prime over here. I'm using triple prime to differentiate between that prime there and this double prime here. Okay, this is a closer look. That A becomes A triple prime, and so on. Of course, what you are seeing here is a clockwise of 90, which is the same as an anti-clockwise of 270. And you draw in image 3 by connecting A triple prime to B triple prime to C triple prime, and you've got this image. Can we calculate it? Yes. 4, 2 becomes 2, negative 4. 10, 4 for B becomes 4, negative 10. And 10, 9 becomes 9, negative 10. So notice what happens. The y coordinates become the x coordinates over here. They do not change. Whereas the x coordinates now become the y coordinates over here, each one being multiplied by negative 1. So xy becomes y negative x. And we have seen that before. No vertex of object touches any axis. Use the same calculation as in example 3. So 1 to 3 and 4 to 6, they are the same thing. Now example 7. The difference with this is we are not using a multiple of 90 degrees as a rotation, and we are not using the origin. So now we are using C, which is here. Center of rotation is not 0, 0. It is -4, 2, which is here. That's our center of rotation. And we are going in an anti-clockwise direction of 110 degrees. We use the same principles as we used for the last 6. From P to the center of rotation, draw a construction line. From there, measure 110 degrees. And now we will mark a line through there. Take an arc from C to P, and this point here will be P prime. Obviously, we do the same thing with those other two. With R, draw that line, measure 110 degrees, then you will draw a line through here and take an arc from R going all the way out there, which gives us R prime. So we do the same thing now for Q, which is over there. Measure from here to 110 degrees, which is here. Draw a line through that 110 from Q all the way around. You now have the 3 image points from the 3 object points. Join them with short, solid, straight lines. And that is the required image. Now, and those are the general principles that apply to all such situations. Now, when the center of rotation is 0, 0, and the angle of rotation, either clockwise or anti-clockwise, is a multiple of 90, we can also calculate that. Other than that, we will do it graphically as you see here. Now, example 8a, consider triangle RST shown in the diagram below. Draw its rotation of 90 degrees clockwise. Now, all the previous examples, we were dealing with anti-clockwise. Now we are dealing with clockwise at a center of rotation of 0, 0. Okay. So that is how you would see it in notation form. Basically, you do the same thing that we were doing. Draw 3 lines from those points to the center of rotation. Use each line to measure off the 90 degrees towards the right. Those 2 have been done already. That one and this one with that one. The one you are seeing here is from S, which is this. Now that you have that, you use a compass with a metal point here. Draw an arc from T going this way. Well, from T, it will give you T prime. From S here, it will give you S prime. And from R here, you will get R prime. Join those points. I've done it here electronically, and that's our image. Another example like this with a slightly different object. Same principle. From each of these object points, draw a construction line to the center of rotation, and then use each of these to mark off 90 degrees towards your right, because it's negative 90 degrees. That's clockwise. So this is the first one. From here, we have 90 degrees there. And then the next one, from here, you have 90 degrees there. That. And then from this last one here, R, was done. Now that you have that, draw arcs from T, R, and S to touch the respective 90 degrees on this side. And this is what you get. This T would be there, is the middle one. This R will be here, is the one on the left, and this S would be the one on the right of T, to be S prime. You have those, you join the image, and so this is the image that meets those conditions. Can we calculate this? Yes. Negative 2, 5, 2, 5. Remember, we are doing multiple of 90 degrees at the origin. So we can calculate that. So let's see what is the rule. Negative 11, 3, and we get 3, 11. Negative 12, 7, and we get 7, 12. Okay, what is the rule? So as you could see, this 3, 7, and 2, the original y value became the x values unchanged, but the original x value now became the y values multiplied by negative 1. So it is xy becomes y negative x. Recall also when we had to do an anti-clockwise rotation of 270 about 0, 0. That was the exact rule. So a clockwise rotation of 90 degrees at 0, 0 is the same as an anti-clockwise rotation of 270 at 0, 0. So this here is the same as that. Now example 9, we are going in a clockwise direction of 180, and that is indicated by negative. So if this is our object, let's bypass that and come to this one. You know how to do that. Draw these lines from S to the origin going straight through all three of them, because it's 180 degrees. And then from each point, here, you mark off the same distance over on this side. So T becomes T double prime. R following this line becomes R double prime. And S following that circle there becomes S double prime. You have those points, draw the line, and you have the image at 180 degrees clockwise with the center of rotation at 0, 0. Can that be calculated? Yes, and it is the same thing that we have seen before. Negative 11, 3 becomes 11, negative 3. Negative 12, 7 becomes 12, negative 7. And negative 5, 2 becomes 5, negative 2. We have seen this so many times before. So what happens? The absolute values stay the same, but you multiply each one, x and y, by negative 1. So what we have here is xy maps into negative x, negative y. We have seen this so many times before, like 180 anticlockwise as mirror image at xy. So we have seen that 3 times before. Example 10, 270 clockwise, which is all the way around here. Draw this line and measure 270 that way, which would give us this line. S, draw that line and measure 270 this way, which will give us this line. Once you have those 3 lines, you take a compass, measure from there to there, go all the way around and mark off that distance, and so on with the other 2 points. So at this point, we now have T triple prime, R triple prime, S triple prime. This is going around 270 degrees clockwise. We will join those points. So forget that. and that here is where we are, 270 clockwise. Can we calculate that? From here to there, negative 5, 2 becomes negative 2, negative 5, and so on. So what happens here is that the x values became the y values over here unchanged, and the y values here became the x values here multiplied by negative 1, which is this. But we have seen that before. Example 1, where we had a rotation of positive 90 degrees, which is anti-clockwise, at the origin, and this is what we got, the identical thing up here, which means that this rotation here is the same as that one. Now, in all the previous examples, the center of rotation is off or outside of the object. Now, let's consider 3 examples where the center of rotation C is in or on the object itself, not at a point outside of the object. So let's consider this one. This is the triangle. We are going to draw its rotation of 100 degrees clockwise at the center of rotation C. Okay, so this is how you write it in notation form. Well, we will do the same thing that we were doing, except now this center of rotation is in this object. So we draw a line from P to the center of rotation, measure the 100 degrees, mark that point, draw a line through there, and then draw an arc from P to touch that. So we have P prime. We do the same thing with Q. So you draw a line from Q to the center of rotation and measure an angle coming this way of 100 degrees clockwise. Place a mark here. We'll draw a line through there, draw an arc from there to touch there, and that will give us, so this is the angle and that is the arc. So now we have Q prime. That leaves us now to find R prime. Do the same thing as we did for P and Q. Draw a line from R to the center of rotation and measure an angle clockwise like this to 100 degrees. Put a mark here. Now don't be confused by that line. That is not a line. This is not a line from R. I know R is written there, but R is actually here. What you see there is refraction of light from the side of the protractor. This is not a line. Draw a line through there, and now from here to there we will make an arc to get R prime. So at this point we have P prime, Q prime, and R prime. It is looking a little confusing, so we just connect those image points with straight lines, and this is our image. We will do this only graphically. Now, example 12. PQR, and the rotation is 70 degrees clockwise. This is the notation form here. Now notice what would happen. Remember, we were drawing a line from these vertices to the center of rotation. Well, we already have 2 of those lines drawn, from P to C and from R to C. The only one we would have to draw is from Q to C. So this is easier than the 3 lines that we were drawing, or even 2 lines. So in this case, from Q to there, we draw a line, measure clockwise 70 degrees. That is clockwise 70 degrees. we will draw a line through here and then draw an arc from Q to touch that line. So that is the 70 degrees. Now we have to draw an arc here. Draw an arc using that point and this point. Draw an arc coming here, and this will be Q prime. Well, we already have a line from R to the center of rotation. So all we need to do is place our protractor there, mark off 70 degrees here, which gives us this line at 70 degrees from here to there. We will now have to draw an arc from here to there with the metal point of our compass here. And that gives us R prime. Now we need P prime. So now we place our protractor along P to the center of rotation, going clockwise 70 degrees, draw a line through there, and now we would have to draw an arc like that. Or you could just measure from here to there, that same measurement from here to there. From here, going around like that. This here is P prime. So at this point, we have P prime, Q prime, and R prime. All we will need to do is to join those points with solid lines, center of rotation, 70 degrees clockwise. So we join P prime to Q prime to R prime back to P prime. And that triangle in red is the image, as example 12. No, we are not going to bother about calculating that. Now, example 13. In this case, this is our object. We are going to rotate it 60 degrees anticlockwise, and the center of rotation is C, which is actually Q, which is 4-1. Center of rotation is here. Now, you realize that previously we were drawing lines, construction lines, from these vertices to the center of rotation, and then measuring 90 degrees from there. In this case, it would be 60 degrees from there. Well, now we already have the three lines. We have two lines from P to Q and R to Q. Q is already at C, so we don't even have to draw a line there. So from P to Q, you measure 60 degrees this way. That's 60 degrees. And now you will draw an arc, taking that measurement, coming down this way, which would give us P prime. Well, we will do the same thing for this R here. From R, going that way, 60 degrees, that is from here to there, 60 degrees, we will draw an arc from here to there, using this as our center of rotation. And at this point, we have P prime and R prime. Well, where is Q prime? The thing about it is, Q prime is actually this exact point, because that is our center of rotation. So we don't have to draw any line, we don't have to measure any angle. C, Q, and Q prime, they are all the same point. So Q prime, we draw straight lines connecting P prime to R prime to Q prime, and we get the image for that object. So we finished 1 to 13. They're fairly simple. One principle really you had to learn. Now, example 14. If you are given the object and the image, how do you determine the center of rotation, the direction of rotation, and the angle of rotation? Now, this is what we'll spend the next few minutes on. So this is the last thing we are doing on rotation. So if you are given the image and its object due to rotation, how do you find the center of rotation and also the angle of rotation and the direction of rotation? Let's do a little review on circle theorem. That was video 13. We looked at those, but the one that concerns us right now is this last one here. It says the line joining the center of a circle to the midpoint of a chord is perpendicular to the chord. So if you have a chord like this, you find the midpoint, meaning those two sides are equal to each other, and you draw a line from this midpoint to the center. What this theorem says is that this angle here is 90 degrees. It's perpendicular. This is really the same thing. A chord, you have a perpendicular bisector here, it will pass through the center. Now, this is what we will be using. So we will use the converse of this circle theorem. The circle theorem says that the line joining the center of a circle to the midpoint of a chord is perpendicular to the chord. We will look at the converse and say that the perpendicular bisector of a chord passes through the center of the circle. As long as we know the perpendicular bisector, that will always pass through the center of the circle, wherever the center of the circle is. Midpoint, center of circle. This perpendicular bisector will pass through that center. So what we will do, if we have a circle and we want to find its center, we don't know it, we'll draw a chord like this, get its perpendicular bisector and draw a line like that. That line will pass through the center. So the center must be somewhere here. Now, once we know that, we will take another chord somewhere on this side. So the perpendicular bisector of any chord passes through the center of the circle. We will take another chord on this side and we will bisect that. So this perpendicular bisector must also pass through the center. So now common sense will tell you, if this perpendicular bisector passes through the center and this one passes through the center, then obviously where those two bisectors intersect, that is the center of the circle. So we will use that concept in this last part of rotation. So consider these here. Now you actually have 3 concentric circles. This one here, this one here, and that one out there. But they all have this center of origin. Now, if we could construct a chord from here to here and find its perpendicular bisector, it will pass through the center of that circle. And if we do the same thing with that circle out there, that perpendicular bisector will also pass through the center of this circle. But those two circles are concentric, meaning they have the same center. Okay, that is our clue. So if we draw a chord from here to here, from T to T prime, get its perpendicular bisector, it will pass through the center of that circle. We can do the same thing from here. Say R to R prime or S to S prime. Let's take R to R prime. Perpendicular bisector, it passes through this point. Now that's all we need. You can do the S to the S prime. It will also pass through that same point. Now, the way to understand this is that these circles are concentric, meaning they have the same center. So if you find a line that would pass through the center of that circle and a line that would pass through the center of that circle, where those two lines intersect, that will be the center of all these concentric circles that you see here. So we have an object, this is example 14, and we have an image. Our task is to locate its center of rotation and state its direction and angle of rotation. Once you understand the first part of this, it becomes very easy. You will draw a construction line from one vertex, say P, to its image, P prime, and construct its perpendicular bisector. So from P to P prime, construct, so you draw a line there, that will be considered as the chord of a circle that we are not seeing. You bisect that chord. This line here will pass through the center of that circle, that this line here is a chord. So the bisector will pass through the center of rotation. We do that with P and P prime. We do the same thing with two other points. Let's take R and R prime. Draw this chord. Remember that chord is part of that chord joins the circumference of a circle that you cannot see right now. We bisect this, which is this bisector, project it, and where they meet there, where the two bisectors intersect, since they both pass through the same center of rotation, that will be the center of rotation. The points where the two bisectors intersect is the center of rotation. And if you are doing this and you want to try the Q and Q prime, you could try it. You will end up with this same point. Now that we have the center of rotation, we want to find the angle of rotation. Draw a line from R to C to R prime, or you could go from P to C to P prime, or you could even go from Q to C to Q prime. Doesn't really matter. And measure this angle. So draw two construction lines from one vertex, R, and its image to the center. And you measure that using a protractor, as you could see, from here to there. That will be 60, 70, 80. So this is an angle of 80 degrees, and you can already see that it is clockwise. So measure the angle. We get 80 degrees clockwise. 80 degrees clockwise, we have the center of rotation. You could write it down like this in standard format. A rotation at -4, 2 in a clockwise direction of 80 degrees will give that image. And that should suffice for rotational transformation. So in this video, we were looking at rotation, which is video 16 based on objective 8 part 3 in section 8, rotation.